You can go to jail for a long time for this.
What, free TV?
It's not free. It's like stealing.
Stealing? You guys are beaming a signal in this fucking trailer park with my permission, not me. So I've got these little things that pick up that signal from space. How the fuck is that stealing? What, do you own space?
I'm speaking to you on a channel that only someone receiving programming without proper authorization can view. So if you're watching me, you're a satellite pirate.
I want my fucking satellite signal!
Danny, chill the fuck out. I'm fucking trying here. It'll be back up in a bit. Calm the fuck down.
Hey guys, welcome back to the channel. And if you were part of the scene back in the day, hung out on the user group alt.dss.hack between 1998 and around 2005, you're going to find this video really interesting. And we're going to dive into the hacks that were done on the satellite cards and receivers that were used by Dish Network, Bell ExpressVU, DirecTV. And you guys over in the UK, this probably applies to you too, since DirecTV used NDS cards, which tied back to Sky TV and Rupert Murdoch's company. So yeah, stick around guys, this one's going to be interesting. And I spent a lot of time and work getting all of this stuff to work again. You'll see. And yeah, that is a Pentium 2 computer to the right. And that one is being used for J-keys. So on the left, yeah, that's a tough book. And we're going to run on that one, Niagara Edit, and also Basic H, which was used for DirecTV cards. And down below here, I have various cards, but I've also got this programmer. This was used for DirecTV, and this was a White Viper. I've got right here, this is a Mikaboo, and this was used for DirecTV. It was used for H cards, HU cards, and I'm not sure, I think it had an unlooper function. Over here, this is an unlooper that was used. This was a Milli all-in-one, and it could do H cards, HU programming, and also unloop. And I believe the rewiring on there was to unloop HU cards, which came along later on. This guy here is known as an AVR, and it had an Atmel chip on it. This could emulate Dish Network and Bell cards. Yeah. One thing unique about DirecTV's cards was they had an ASIC chip internally. You could never fully emulate the card. However, there were emulators which used the card's ASIC. It enslaved the ASIC and ran, protecting the card, because anybody that didn't do that found out during the Black Sunday ECM where they actually damaged the bootloader in the card. However, there was a fix for that. It was so funny. It didn't matter what the providers did. They did some serious ECMs. Dish Network had one that would damage and rewrite the receiver's TOSA, but we had an ability to JTAG the receivers and go in there and fix it, and then put digital locks on the receivers so they, you know, it was kind of funny. It was a really cool time to be a part of, because it was a real cat and mouse game, and it was a real challenge, but it was also a lot of fun. And the reward at the end of the day was you got free TV. Well, you were testing, right? Okay, guys, stick around. We're going to play around with all of this stuff and bring back probably a lot of memories. I totally forgot about all this stuff, and I spent about 3 days trying to get everything to work again, and restoring that computer on the right was probably the hardest part. That is a Pentium 2 from 1998. I needed it because of the parallel printer port, which is right there. It's very hard to find a parallel printer port on a computer these days. Just does not exist. But that cable is running to that 301 or 3100 receiver, and we are going to JTAG that guy with J keys momentarily. So stick around, guys. A lot of exciting stuff's coming up, and I think you're going to love this. Okay, guys, I've been working hard on this one for you guys. So, okay, get ready, guys. Here it comes. Just got to love that desktop from 1998. Jessica Alba, the Dark Angel. You guys probably remember her, too. Anyways, let's start with the hardware here. And first of all, the White Viper. This was a very basic programmer. It sold for about $80. It was all you needed, and RS-232 hookup to your computer, which everybody had in those days before the USB era. And as you can see, in 1999 is when that socket was made, the 27th week of 1999. So yeah, this is all you needed. This was a very basic, straightforward. It just did RS-232 to TTL to, this was ISO 7816 standard, the chip pinout, which is what the smart chips use on these cards. On the back here, it's known as ISO 7816, and even cards today are using the same standard. However, of course, the chip internally will be different. This one was the Micaboo, and it had dip switches on the back. It was the more advanced programmer. Those dip switches allowed you to set it to do HU. It actually probably says on here somewhere. There we go. What the switches did: HU, H, and flash. I'm not sure if this guy also did on looping. It may or may not have. It may to a certain degree. But this one here was designed by a guy named Millie, and you guys will probably remember him. And look at that, made in Canada, the all-in-one. And this was an unlooper. It had the unlooper ability, and again, had dip switches on it. And I'm pretty sure that upgraded wiring kind of rings bells about being able to unloop HU cards, because the HU, when we switch to those later on, now I'm going to show you the cards. This was an H card, and it's the first card. Well, there was one before it called an F card, and it was hacked quite early on. And of course, you didn't need the card at all. You could fully emulate the card, and there was a device known as a battery card because it had a small battery on it for backing up the memory. And that was F card emulator. H card came along, and they thought they really got us at that point because they put a chip in here which was called an ASIC, application specific integrated circuit. The ASIC itself was never figured out. What it did is a certain number would go in and a different number would come out. It had some kind of algorithm how it worked. However, it was hardware based and it could never be emulated. However, emulators existed to protect the card that you could run on a PC, and you could then connect the card to the computer, and the card was enslaved by the computer and protected, and it was only using the ASIC. Later on, they did HU, which stood for H update, and these cards got hacked quite fast. It was based on the H card. I believe it even used the same data stream, but had some more security features, but didn't really help. Got hacked, and yeah. So moving on from that, we go over to Dish Network, and this is actually the programmer that was used for Dish Network. It's basically very similar internally to the White Viper. However, the clock frequency, the crystal, is different that it's using. That's about the only difference. You could actually have used a White Viper and replaced that crystal, which was a color burst frequency of 3.579. They used 3.6 something for these cards, Dish Network, Bell ExpressVU. And so that was the programmer there. These programmers, all of them connected by RS-232. So that's another thing. You needed a computer with an RS-232 port on the back, and that's what I've got here, just to make things simpler. And okay, guys, so the first thing we're going to do is we're going to use Basic H, which I have over here. You guys probably haven't seen this in a long time. And we are going to play with the H card. Okay, guys, let me set it up, and we'll be right back. Okay, let's start with DirecTV hardware. Back in the day, in 1999, This was the top of the line DirecTV satellite receiver. It was made by Sony and it was known as the A4. And we can take a look at the bottom of this guy. And there it is, the model number, the SAT A4 and May 1999 data manufacturer. Really, really cool to see that. Now, this was the remote control used by that receiver, which some of you probably will recognize. And wow, you were the king back then. If you had 500 channels, all the sports, all the movies you could think of, and you had this little joystick down here to flip through all the channels. This was really state-of-the-art back in the day, and very exciting having one of these. It just totally changed. It was a revolution, actually, in television broadcast. Back in the day when digital satellite started and you were getting all of these channels off a dish that was only 18 inches. So next, we are going to look at how the cards were hacked and what it took to hack that card. If you were a subscriber, even not a subscriber, you could just get one of these White Viper programmers, go online and download a script called Basic H, put your card into that programmer, and go over to your computer. And I will show you what you needed to do. You would go in and you downloaded the scripts and you would have them, let's say, in a folder. And there it is. Now there was Viata, which was the first version. It was later changed to Basic H. We will run Basic H. And it will load. Of course, we always have to wait. These are slow computers. Now, the ATR was the answer to reset, and that was what you wanted to see first. And not seeing an ATR. Let me see. Oh, we have to read card. I forgot how to use all this stuff here. Read card info. There we go. Yes, there's the ATR. Answer to reset. And there's the card information. Now the upper state word was 26. That was kind of a low. Look at the spending limit is $10. So now we can totally manipulate this card using Basic H. And one of the things we'll do, you will see, I'm going to update the card. Yes, we're going to update the upper state word. And it will start. You can see the programmer is doing something. The light is flashing. The right light is flashing, so it is writing to the card. Okay, so what it says, it's opening the hole. So these were security holes in the card that were being exploited. Basically punching a hole through, like, enabling update handler. Now you needed to update your card in order for after an ECM, but what they were actually doing with these updates, they were introducing dynamic code. And there was a few people out there that were very concerned about this, and rightfully so, because eventually the dynamic code was used once it was all there to do the Black Sunday ECM. And DirecTV, it was always amazing to me. They spent probably millions of dollars engineering this attack. And ECMs had to be very carefully crafted because it had to only attack and damage illegitimate subscribers or people that weren't subscribed, and not damage their legitimate subscribers. And sometimes ECMs actually did damage legitimate subscribers' cards. And receivers. Dish Network had a lot of problems with that too. I'm sure there was people fired on their engineering teams for messing that up because that was very costly to them. So we are still writing here. Are we done? Oh, look, it's adding updates. Wow, it's still going on and on. 22, 23. Yep, you had to have a lot of patience with this stuff, but it did work. Closing the hole. Okay, so it's done. Now we'll see when it restarts here. Upper state words is 28 now. So that's how that was done. Now you had other features on here. Wipe pay-per-view. So basically you would unplug your phone line on your receiver. You would, because you had a certain amount of credit here. We could probably add some credit, more than $10, but yeah, it would be holding that pay-per-view purchase like WrestleMania with Hulk Hogan, and you know, those things were always very expensive, and you could watch it and then take your card and just wipe the pay-per-view. This was something that if you were a subscriber and you just wanted you know, not pay for the pay-per-views, you could do that. Some people felt better about doing that. One step clean. Oh, and we could take it back to a particular update. Okay, what is this one? Read EEPROM. Okay, let's try to read the EEPROM. So it's looking at the E3 hole, probing the card. So now it's using these other holes. Reading the EEPROM. So now it's dumping the memory space. Oh, timeout. We have a little problem here. Houston, we have a problem. Anyways, looks like it stopped. But so that's basically how Basic H worked. And anybody could download this from the internet, run it on their computer, and manipulate their card. It was that easy. Put your card back and get free channels. So, and there were scripts that you could download also, patch it to your card and get all the channels for free. So there you go, guys. So we're going to move on now to Dish Network, which is also same hardware was used for Bell, and probably some other providers that used EchoStar and NagraVision. So we'll move over to that now. Stand by, guys. Okay, guys, we are now going to start with EchoStar equipment, which provided equipment to Dish Network and Bell ExpressVU. This receiver here was known as a 301 on Dish and a 3100 on Bell. I have now the Bell card in the programmer. This is a programmer known as an Akira programmer. And we are going to run something called Nagra Edit momentarily on this card, which is going to allow us to access the card and manipulate the card in any way we want. These cards were actually made by a company that provided the security called Nagra, and they are a Swiss company. And they still provide security. They finally figured it out, and their system is secure now with Nagra 3, as far as I know. So here we go, guys. We're going to start Nagra Edit up here, and this card that's in the programmer, we are going to access it. And there it is there. Nagra Edit is running. And we go here and we are going to read the card. Now this is what it's going to do. It's going to break its way in through against security flaws in the card. They were known as holes in the DirecTV cards. Over here we call them back doors. And there it is. It's dumping the code space, which is the EEPROM. And that's really what you want to get to. Once you've dumped the EEPROM in a card, it's pretty much game over for the security of the card. The card is now completely compromised. And there we have read the ROM 10 card, the read-only memory 10. And we can go over here and look at the dump. And right at the beginning, there's a very interesting thing that was really kind of weird. Remember the pirate ship on the motherboard that I showed in my previous video when we were hacking the satellite receiver for the hotel? It's just weirdness. Again, here we find some more weirdness. Nipper. See that? Nipper is a butt liquor. What on earth does that mean, and why is that in there? And it was in all of these Niagara cards. The best answer I ever heard was that Nipper was the name, and actually this is true. Nipper is the RCA dog, that white and black mascot that they always had. And RCA made receivers for DirecTV, which was the competition to, Dish Network. So possibly that's what Nipper is, and Nipper is a butt licker, and dogs do lick their butt. So possibly that's what that's all about, but who knows? But just again, some weirdness that is embedded in there in every card. Nipper is the butt licker. So let's go on, guys, and we're going to go into the data editor. This card was wiped. It's clean. So you will see there's no IRD number, box key. Everything is zeros. But once it was married to a receiver, you would have a receiver number. Now, if it was married by the provider and subscribed, we will be able to extract the box key. The box key is something that was really an interesting feature. It was kind of a security interlock. The receiver itself, in its ROM, has a unique box key, and the box key is only known by the provider. The provider, when they would subscribe the card, would send that same box key to the card, and this card could only work in a receiver with a matching box key. So that was a security interlock. Down at the bottom there, the public keys 0 and 1, those were the encryption keys that would change, usually daily. You'd have to update those. If you didn't, you wouldn't get any TV. And but eventually, all this stuff was figured out. Scripts were available that would automatically roll keys when they were changing the keys. And they started changing the keys actually like every half an hour. So, and then there's all these other decrypt keys. The EMM, that stood for Entitled Management Module. The keys, those were how they sent and talked to the card over the satellite securely. Well, not too secure once it was all known how it was done. But that's basically that. You could also do other things. You could add tiers, packages, which allowed you to, kind of, if you were a subscriber, you could just, do certain little things to your card, like add a certain package that you weren't supposed to get. Patches could be done. There were so many different functions that Niagara Add Edit allowed you to do. But mainly, most people use this just to turn everything on. And also a pirate card, that was never even subscribed. Now, if you had a pirate card in a receiver and you didn't know the box key, I'm going to show you how that was done. And things got to a very sophisticated level very quickly. Most of the people that were involved in this scene were actually professional people out there in the world, engineers, programmers, and everybody would get online together thanks to this thing that was kind of new at the time called the internet, and hang out in the alt.dss.hack newsgroup. And that's where really things happened. And, you had a whole army of hackers out there working together for fun, creating all this stuff. And it was an amazing time. And those providers had quite an issue dealing with it. Eventually they got things clamped down, but it took years, and there was card swaps, and I could go on and on. There's quite a history. It was very interesting. And they learned the hard way, but eventually they secured things. So, okay, guys, the next thing I'm going to show you is J-keys. Stick around. And then came the JTAG interface, and this was a game changer in a huge way. How it all started was, there we go, that is the pinout and how to wire it up. And that is what you're seeing on the back of my receiver. But it all started with a guy over in Russia whose name was Thomas Vlad. And he was trying to figure out a way of reading the firmware in DVD players so he could change the region code or make the DVD player non-region code controlled. He wanted to find a way of bypassing that, which he did. And those were Panasonic DVD players that he was playing around with. And it just so turned out that the JTAG interface on these Panasonic DVD players was the exact same as what was used on EchoStar satellite receivers. And actually a lot of other products, I remember Linksys routers using the same JTAG interface. If you bricked your router with, what was it, DDWRT, bad firmware update, you could recover it, because what the JTAG is it is a direct connection into the CPU. Now, the CPU has on board what's known as a diagnostic control unit. And you're directly talking to that diagnostic control unit. So you pretty much have control over everything. It overrides everything going on inside the device. And it was designed basically for the factory to be able to test the device, speed up testing. And JTAG stands for Joint Test Access Group. It also allows for firmware to be uploaded into the memory of the receiver, which became very helpful not only in manipulating the receiver's internal firmware, but if the firmware was damaged by the provider during an ECM because they detected you were unauthorized, you could fix your receiver very easily. And also, number one reason why this was done, JTAGing, was to get the box key so we could either use it with an AVR like this device here, a card emulator, or if we were just programming a card itself that we had that was from a different receiver, we wanted to use it on our receiver. Say we bought a card somewhere on the internet, we wanted to use it, we needed to know that box key. So basically, yeah, you would just plug in and there you go, guys. That's the JTAG interface, and there's the box key of this receiver. And that's all there was to that. Okay, guys, we're now going to move on, and we are going to JTAG this receiver to extract the secret box keys. And we're going to use a script called JKeys to do that, which I remember was created by a guy named Dave 2. So Dave, if you're out there watching, this is for you. And the JTAG JKeys was an amazing feature because it also allowed you to restore your receiver if it was hit by an ECM, because that eventually started to happen too. Okay, so here we go. 2. JTAG your receiver. We're going to power it up, and as soon as the CPU gets power, it's going to allow us to access the diagnostic control unit. And we're going to go over here and we are going to run JKeys. As soon as I open this, it should read the receiver's memory. And there it is there. And if I zoom in, there's the box key. Just like that. That's all there was to it. The hardest part was actually just wiring in. It was very convenient that they had that hole in the bottom of the receiver. They actually stopped doing that later on because they didn't want to make it so easy for people to be able to extract the box keys. But that's all you needed to do. Once you had that box key, the secret key, you could program that in as AVR here, which was a card emulator, and then take that emulator and place that in your receiver like that. And it just was like an access card was in there, and it would turn everything on, all the channels. Now that parallel port where you would program your AVR, eventually, as things got more advanced, you could leave a parallel printer cable plugged into it all the time, connected to your computer, and it would receive automatic key updates as they changed the keys. Now the keys, there was always 2 of them, a 0 key and a 1 key. They would roll keys. They would roll between them. They would frog leap. So as long as you had the updated key on your card or your AVR before the key change or the roll took place, you would have uninterrupted TV. So that's how that worked back in the day, guys. I hope you enjoyed that. Stick around. I have some behind the scenes of me figuring all this out over 3 days, and also this Pentium 2 computer, which is a real beauty. Again, this is from that era, late 1990s, these Dell towers. Yeah, I'm going to show you the inside of that, and the Pentium 2 processor, which is pretty funny to look at. Yeah, this was an amazing computer too. I remember when I got this, I actually got high-speed internet that day because this computer was ordered with a network jack. It didn't actually have a modem in it. And I got a 1 meg cable modem that day. And this computer, and I went from using, it was a Pentium 1 with a dial-up modem. I went from using that to this computer with a 1 meg modem. And it just totally changed everything. It was a total game changer. So I kind of very sentimentally love this computer. Kind of was life-changing for me. So stick around, guys, and I'll show you the behind the scenes coming up of how I got all this working again and figured it all out. Okay, stick around.
Hello, I'm Brian Olson for Dish Network. If you can see this channel and see me, you need to know that you are breaking the law. This message is being broadcast to you on a channel available only on satellite systems that have been illegally tampered with.
Okay, guys, a little bit behind the scenes. For the last 2 days, I've been trying to JTAG. This is the hotel receiver, as you probably recognize. I've wired into the JTAG interface, and I have it connected to this old Pentium 2 because I need a parallel printer port. And this old Pentium, Dell Pentium 2, has been a real pain in the ass. Runs on XP. And yeah, every time I boot it up, I have to go through a whole bunch of different menus because it's trying to install things, and just to get the mouse to work was a real issue. But I do have it working, and but it is not detecting. So I'm gonna try a couple other receivers. I'm thinking this hotel receiver, maybe the JTAG part was disabled somehow. So what I got over here is this was a Model 6000 dish receiver, and it was made by JVC, which was really unusual to see that. Typically all the receiver equipment was made by EchoStar, but yeah, really weird receiver. I did find internally on the JTAG connection there was already one of these wired up, and that's how a lot of people did it in the day. You just could plug in easily, which is the network connector. And you had obviously a cable that was wired to a parallel port, but there is this little wire here, and that kind of reminds me of something. I remember on some of them you had to ground a particular line on the main CPU chip to get it to go into a write mode so you could program those TOSOP chips. I believe that. I don't really want to program anything. There's no point. I just want to read it just for the history of it all, just to document it. Love to be able to get one of these JTAGing. So I'm going to try this one next. I am currently making another JTAG cable, and that's what it looks on the bottom, and the JTAG pinout. And basically, yeah, you would just take a parallel printer cable, and it's pins 2 through 6, and I think it was 13. That's what those wires are. And you pick a couple other ones that are grounds to ground the thing. So yeah, and what I have here, this is, let me see, you recognize this one as it's a Model 3100. It was also known as a 301 if it was Dish Network. And there's the JTAG there, which you can see has been untouched. And momentarily, I'm going to try also to JTAG this guy. And yeah, so there you go. That's what we're going to do next. Okay, well, hopefully get one of these working. Okay, so I made up another JTAG cable, and as you can see, it is wired in there. Red, orange, yellow, and this is a light blue and green. And the other two wires twisted together, just grounds. So there you go. And this is a 3100, also known as a 301, if it was used for dish network. I have that now plugged in to the back of the Pentium 2 computer. Look at this beauty. Isn't this wonderful inside? Look at that Pentium 2 microprocessor. Wow, with MMX technology. I mean, this thing, it doesn't even look anything like a microprocessor does now. It looks almost like a big printer cartridge. Anyways, let's plug her in, see what we get here. There we go. Power is on. Green light. Okay, now let's go start J keys. See what we get, guys. Let's keep our fingers crossed. J keys, Dick. Yes! It's working! Absolutely amazing. Look at this. It's working. Oh my God, guys. Yes, I am so stoked right now to see that actually working. Oh my God. And look at that, it detected it. There is, okay, so this is why this was done. See the box key? That is a secret key, which was unique to that receiver. And the access cards, which were one of these guys, didn't know what the box key was. It was sent by the provider over the data stream to the card because they knew they had some kind of table. They would do a lookup from the receiver number, and I guess EchoStar would provide them with what the box keys were. It was very secretive. And the box key was sent to the card separately. And the card could only work with the receiver if it knew what the box key was. It was some type of an interlock security system that they had in place. And it was quite secure until people were able to JTAG the receivers. There was only two ways to get the box key. One was to JTAG. The other was to read it from the card. But the card had to have been subscribed before in order to have the provider put the box key on the card. The other way, which was very difficult, was actually to remove the TOSIP chip from the motherboard in the receiver, and you would have to have the equipment to read it to the computer equipment, which, you know, it would be very high level to be able to do something like that. But that was actually the first way of retrieving box keys, where they were actually removing the TOSIP chip right off the board. So let's see, guys, what can we do here? Just gonna try to hold this. You know, I love to be able to do this with OBS running on this computer, but obviously OBS would probably kill this thing. It's only got 120 megs. Let's see, flash. What can we do? Detect. Let's try that again. That's the same thing. EEPROM programming. Okay. Wow. Let's download it. Can hear my hard drive doing something. Development panel. Save memory. I have no idea what I'm doing here, but it is just really cool to see that this is working. Wow, what have I done now? Okay, then we're back to that. Oh, what is this? Save as. Okay, let's save it. like to do is just try to dump the memory. Port diagnostics. Flash EEPROM programming. Not really sure how it was done, but you could. Oh right, there's 2 flash chips in these receivers. So okay, save. Not really sure what I'm doing here, but it is working, and that's really cool to see. This is all I really wanted to do. Let's try it again. Let's reboot. And yeah, it automatically detects. So IRD number, see the number there, 37156871. Let's go look at it. Should be on this box here somewhere. Yeah, on the back here. 37156871. I see it right there. So yeah, we are JTAGing this guy. Really cool. Okay, guys, that is really, really great to finally get that working. Been spending quite a couple of, probably 2-3 days on this right now just to get it to do this. That computer was a real pain in the ass to get going and resurrect, but it works. I got it going. So, okay, guys, let's do some card programming now. Okay, for you computer guys, just want to show you what kind of computer this is. It is a Dell XPS R450. This is Pentium 2 machine, 128 megs of RAM, and we are going to start her up here. I'm just going to show you guys that are interested. A lot of you old guys like the old computer stuff. And we'll come around here. You can see the, there you go. Dell.com, the splash screen. Wow. You're going to see how long this thing takes to boot up and all the problems it has. There we go. Okay, so it's got 1998. This is when this machine, when I purchased this computer, was in 1998. So that makes sense. The BIOS there, the copyright. And so it's a Pentium 2, 450 megahertz processor, 128 megs of system RAM. Wow. And the floppy drive doesn't work on it. It's stuck, so I disconnected it. So that's why we were getting that error. So we will just go over and press the escape key, and it will continue to boot here. Of course, it takes forever. It is running on, there is a Maxtor hard drive inside there. Not sure what the size is, but we can always take a look. It's IDE, obviously. And there we go, XP Professional. Now, this computer shipped with Windows 98. In 2001, it was upgraded to XP Professional. Because, and you know, XP was really when they got things really good and stable. XP apparently was based on NT, and Windows 98 historically had that blue screen of death that just kept occurring all the time. And that's basically why I got rid of it. Welcome. Now, the hardest thing I had problems with getting to work was the mouse. But there we go, look at that. Still got the, I used this computer up to about 2003, and I got my next Dell after that. Yeah, you see the mouse, let's see, yeah, the mouse is not working, and I get this issue here. I don't know why it does that. HID, human interface device. So what I was doing was I would just go over and just, there's 2 USB slots, and it was actually the first time in 1998 I ever saw USB. And this sometimes helps stimulate it. because I can't get rid of this stupid screen. Okay, let's just let it do whatever. Finish. So is it going to work now? No, it's still not working. Okay, oh, the hub. I have a hub plugged in. It's so stupid, like Microsoft, it's not certified and you have to agree to it. There's probably some legal reason they did that. Okay. Mouse is still not working. Oh, and the mouse is working, finally. Okay, cancel that. We don't want to do anything. And, yeah, just cancel. So, what? Oh, man. These computers back then were just, what a pain in the ass they were. So, okay, now I'm going to plug in down here. This USB stick has got J keys on it. Oh, the other thing is the first USB stick I used, it was a 32 gig stick. This computer didn't even recognize it, wanted to format it, and then I realized what was going on. It can't see anything past 4 gigs, right? Because it was a 32-bit system. So I got this old Memorex USB stick, which is 256 megs of memory. And, of course, that'll work. So now we can go over here to my computer, and there's the removable, the USB stick, and that has J keys on it, just right there. So now let's plug that satellite receiver back in. There we go. And run J keys. And there we go. J keys is working. Let's try it again. Detect. Oh, there we go. Detect. Look at that. It's different. Okay, well, there we go. We got J keys, and I showed you the whole boot up sequence, and it's only 6.5 minutes it took. But that's what it takes to get one of these old computers working. And, okay, guys, I hope you enjoyed that. Have a good one. Hey, guys, welcome back to the channel. And what I got running in front of me here is a DirecTV emulator. This is an SLE emulator, the complete setup with H-card, which was known as the aux card because it was fitted with a script, the aux script, which allowed the emulator to just pump dump the ASIC chip that was on board the card. The card had no other function because the emulator had a virtual card running in its memory. And that basically allowed destructive ECMs, which eventually came through with the Black Sunday ECM, could not damage the card itself. It only affected the virtual card, which immediately would have reset itself and reloaded, and you would have not even lost TV that night. That Sunday night, according to Wired Magazine, destroyed over 100,000 of these H cards that were out there that were hacked. And according to DirecTV, they believed 98% of the hack community was taken down that night. Probably was true because not a lot of people were running emulators. Emulators were quite complex to set up. First of all, you had to modify your receiver. Basically, you use something called a Zapulator, which was a TTL to RS-232 interface. And there is the schematic for it right there. Not very complex, but basically a lot of people use the telephone jack on the back of their receiver to plug into, and that was just wired to the card slot. This receiver no longer has a card slot. It was through the back right there. It's missing on this receiver, but the telephone jack allowed you to just unplug your emulator and put your card straight in if you wanted to run it straight in the receiver again. But most people who used an emulator didn't want to do that. So basically from here, you had RS-232 going to a computer that was a 286, 386, 486, maybe a Pentium 1 at that time. This is a 486, this computer here, an old Patriot, which has an IBM CPU inside it, and two RS-232 ports on the back. This one here is coming from the receiver, and this one here was looped back around, and inside the computer, the H card was just conveniently located inside, probably inside the drive bays. And you can see there it's actually getting power. It was wired in to get 12 volts to run. The card reader, which is the White Viper, also known as a Phoenix. Somebody mentioned that in the comments in my last video. That is true. So we're going to actually start this up. This computer has some issues because the BIOS battery is dead. And we'll get into that momentarily, guys. So stick around. This should be interesting. And we will continue. This is not my last video doing satellite hacking. We will continue with the history of FTA next in my next video, and then we will do IKS and Fusion, and that will take us up to around 2008, and that's where we will leave it to be. Okay, guys, stick around.
Look, if these satellite dishes aren't down in 10 minutes, I have no choice but to call the cops.
Ricky, get the dishes off my roof. Listen, man, I just got out of jail. Don't be calling the
Dino,
cops.
take them down now.
Ricky, get the dishes off my roof.
Dino, call Mr. Slade.
Really cool photo I found online of a guy that had 3 emulators running at the same time in his house, three receivers in his house. Pretty cool, the lengths people went to, but you had to back in those days. If you were not running an emulator, you found out the hard way. Now, why people were running emulators and why they knew about it? Well, it was due to the introduction of dynamic code. DirecTV started to do multiple updates very quickly, and there was always a little bit of extra code in there that didn't make any sense, but it made sense on the last update they did, and it was all it was dynamic, and all the pieces fell into place, and we knew what was coming. So I advised everybody I knew, run an emulator, but a lot of people didn't because it was complex. You had a lot to set up here and maintain. But eventually it became the norm. After the Black Sunday ECM, everybody wanted an emulator. So anyways, this was an emu that I had running back in the day. It actually survived the Black Sunday ECM. And I found this floppy in it, which says CEMU on it, 2700. That was a Dish Network emulator, so that was probably later on. But definitely this was used for DirecTV, and I have put SEL on that disk and made it bootable. And believe it or not, I had to Google how to make a floppy disk MS-DOS bootable because I totally forgot. Yeah, you know, you can't remember everything, but this is MS-DOS this thing is running on. So it goes back a long time. Now, this computer has a little issue with the BIOS battery. Those of you that say, well, why don't you just change the battery? Well, you can't because it's using one of these. Remember the Dallas chip? The real-time clock, RTC. But look at the date code on it, 87? 12/8/87. So it's like December 8th, 87. So that chip, which is removable, yeah, it looks like it's in a socket. It is a RAM chip. It's volatile memory, and it had, I believe, that's a lithium battery on the top. It might be alkaline. I'm not sure if we had lithium back in 87, But it did last quite a while because it wasn't a problem 20 years ago, but it's definitely dead now. So the BIOS is corrupt on this machine. Look at that, nice IBM. Wow. You couldn't get better than that, man. IBM. So anyways, we can deal with the BIOS issue because we just want to get it to boot. So what we're going to do is we are going to start, and it's going to boot up, and we will see momentarily the blue lightning, IBM. Wow. From 1994, I remember purchasing this computer around 1995 for my security company business I had at that time. So here we go, guys. It is booting up. Look at that. We have 640K of base memory, and then we have some extended memory. Commodore 64. I actually had an Atari 800 XL before this, so I was an Atari guy back in the day. Look at that, 66 megahertz processor. Wow, incredibly fast. But you know what? I did a lot of stuff with this computer back in the day. It actually got me on the internet. This computer had a modem in it, and I remember turning it on for the first time and thinking, I want to go as far as possible as I can go on the internet, and that was in 1996. And I went to Auckland, New Zealand, to a university there. I think it was the University of New Zealand. And I got into the faculty directory and was looking up professors there, which was really incredible to me because in those days, there was no other way to do that. The only way would be to phone them. So, okay, we have corrupt values. So, continue with corrupt values. I'm just going to continue with corrupt values. Continue. System setup. Okay. Restore settings. Okay, guys, I figured it out. All we need to do is just exit when we get this message, and it will go straight to the floppy disk. Green light is on. It is booting MS-DOS off the floppy, and then it will do a batch file, which will take it into the SLE44 emulator, which is what it's doing right now. Just loading off that disk. And there we go. The SLE44, and with the Milli-core, the Milli-4 core. And look at this. Pierre G. Martineau. He was a guy out in Quebec that created this emulator, the SLE emulator, and he was the one and only guy, from what I recall, that knew anything about these emulators, and he continued to maintain it and give updates as they were needed, because DirecTV did actually start ECMing emulators. They weren't able to damage anything, but they were changing things, just causing the emulators not to work. Now, this is really funny. He's asking for donations through PayPal at the following email address. And I know today that PayPal account would be taken down really quickly and you would lose all your money in that account. Yeah, this must have been way back when, in the year 2000. Is there a date on there? 2002. Probably Elon Musk was still running it at that time, and nobody really cared much. Would have been much more difficult to do anything about that PayPal account. So there is basically all there was to it. The floppy ran a batch file. It would automatically boot, and everything would come up. You didn't even have to have a monitor connected if you didn't want to. It all ran on its own. You didn't need a keyboard or anything. And there it is there. And it is probably going to be trying to talk to the aux card, which is not fitted with the proper script. So we will momentarily probably get some kind of an error message here because it is trying. Or you know what? It might actually work. I'm not sure what's on this card. It could actually be the aux script for all I know. Anyways, There you go, guys. And we're now going to take a look at a little bit of the history and the people behind the Black Sunday ECM. Very interesting story, so stick around. So, 8:30 p.m., January 21st, 2001, the Black Sunday ECM is unleashed, destroying 100,000 cards that were hacked at the time and removing 98% of the hacker community. And DirecTV, to add insult to injury and a little pizzazz, as they claim here, signed all the cards, with the first 8 bytes all reading game over. Well, little did they know that these cards would be recovered down the road with a bootloader. But it was a pretty devastating attack. It took a couple of months to recover from. And wasn't known for about 8 years until Wired magazine exposed Christopher Tarnavski as the mastermind behind the epic Black Sunday attack. So there you go, guys. And we're going to take a look at him next.
Christopher Tarnavski is a hacker who specializes in hacking smart cards. He was so good at this that he was actually hired by a company that makes smart cards for the satellite TV industry to help them secure their systems from satellite pirates.
So today what we're going to do is we're going to take out this piece of metal, we're going to remove it, we're going to expose it to some acids. The first phase is going to remove the epoxy and actually expose the chip. So this white stuff's going to come off. So basically the plastic's broken down now after about 10 minutes have gone by. First phase of exposure is going to be to get to the actual device inside the substrate. We're going to pull these out and we're going to stick them on the hot plate with some fuming nitric acid, HNO3. Very, very dangerous. It's a very aggressive acid. You can see on the monitor, it looks good. It looks beautifully clean. Scratch a hole in this area. And I really don't need to open the whole area, but I basically want to touch this middle area where their data bus is and the side where there's a control line that I'm after. Now we're going to sit on the bus with a needle 8 times and we're going to listen. The yellow line will be what we're touching on the substrate. The blue line represents reset. Every time I reset the card, we're going to build a log of where the chip went when it powered up. And you're basically going to see everything. So we're going to take 800 hexadecimal samples. So this is just a sequential order of the samples taken. Sample 500 hex, sample 520, and what I saw at the period of time. Anything in the chip, I can see it right here. As we take more samples, it's all going to fall into place and you'll see it. I could actually send a management message, for example, into the chip and eavesdrop everything the chip did to decrypt the message, for example. So if I can see, I can do anything I want to right now. I can control it or I can listen. I can read out the E-square if I wanted to. I could read out the ROM. Anything goes at this point in time versus glitching with a glitcher.
So following the Black Sunday ECM, people were absolutely flipping out.
Where's my goddamn TV?
Oh my god!
Where's my goddamn TV?
However, the hackers were hard at work, and they've discovered that the bootloader in the card wasn't actually needed, that an external bootloader could be used, and that's what this device here is. This was a bootloader sleeve that sat between your card and had contacts on it that went into your receiver, and it provided the necessary boot for the card. Basically, what it was doing was glitching the card into its boot operation. The bootloader fully restored the operation of the card. All 100,000 cards that were hit by the Black Sunday ECM could be resurrected with this device that cost around $100. And there's one there. It could also allow you to use your card now with an emulator, which many people did after they learned their lesson the hard way after the Black Sunday ECM.
What the fuck is wrong with you?
Jesus. Take every fucking one of these down the fucking ground. Is that what you want, you fucking retards? Don't give a fuck about this stupid bullshit?
That windshield was already
Come
dry.
to the fucking park with my fucking permission?
Hey guys, welcome back to the channel, and today we are going to take a look at FTA. and what that was all about. Started around 2004, and well, before FTA, the only way to hack the signal was to use provider equipment and cards. And then all of a sudden, it was a watershed moment, a moment that changed everything as far as satellite hacking ever went. It was probably one of the biggest deals I've ever seen. Suddenly, you didn't need the provider's equipment anymore. You could use these boxes here made by Pansat. Now, Pansat was a legitimate company that made these for the free-to-air market. However, they got a little bit corrupted as things went on, and we'll get into that too, as money corrupts, as they say. But how on earth did this even happen, or how was it even possible? Well, it was to do with being DVB compliant. And starting in 1995 was when the European Union set the DVB standards. And 1996, Dish Network launches, and there's one of their receivers right there, the black one. Now, Dish decided that it would be good for business if their equipment was DVB compliant, because that would allow them to sell their equipment to European providers. Was that a good, wise business decision? It might have been at the time, but guess what, guys? That also meant their equipment was also DVB compliant, were free-to-air receivers, and free-to-air receivers also used the same set-top box chip, the STI series, the 5500. And this board here is actually out of a Dish Network receiver. And if we go over here, this board here, this was the first purpose-built FTA receiver designed for piracy. It was called a Blackbird. This is all that's left of it is the motherboard. But look at the Omega chip in there. It is an STI 5518. That chip, it's the same series. And I'm going to show you guys next, the next coming video I have for you. Watch this, guys. So what exactly is DVB, and what does it represent? You've probably seen this logo on certain satellite equipment, and especially FTA receivers. And you also probably seen it on Dish Network's receivers. And here is the interesting story. The DVB standard was standardized in 1995, and in 1996, Dish Network launched, and they decided to be DVB compliant. And what it actually represents, as it states here, it's a set of international open standards for digital television. DVB standards are maintained by the DVB Project, an international industry consortium, and it's published by the Joint Technical Committee of the European Telecommunication Standard Institute, the European Committee for Electrotechnical Standardization, and the European Broadcast Union. So basically, it's European Union. If you want to sell your equipment or operate in Europe, you need to be DVB compliant. And so let's go down and look at some of these standards here. There's so many of them, but all FTA receivers with the DVB logo and Dish Network's equipment comply to all of these standards. And the interesting one is the encryption. So we look at the encryption. It says the conditional access system, which is the access card. DVB-CA defines a common scrambling algorithm, and the DVB-CSA a physical common interface. The DVB-CI for accessing scrambled content. The DVB-CA providers develop their own wholly proprietary conditional access system with reference to these specifications. So that would mean a company like Nagravision would conform to these standards because they want their cards to work in a DVB compliant receiver. And here we have an early 2700 receiver made by EchoStar for Bell ExpressVU. The same receiver was used by Dish Network. We'll go over and look at a Dish unit, and we'll zoom in on the front. And what do you see there? The DVB logo. So Dish was DVB compliant from the very beginning. And let's go over and look at the chip that is found inside that particular receiver, the STI 5500 Omega. There was a series of these chips. They were introduced in 1997, as it states here. And if we scroll down here, the Blackbird, which I just showed you the motherboard from, it was purpose-built to basically be a pirate box for Dish Network. It is using the STI 5518. When we compare them, you can see the STI 5500 and the 18 are basically the same, but the 18 has twice the static RAM. And yeah, more static RAM was always a good thing because you could then have more running in memory. So, okay, let's go over here now and let's take a look at this confidential document on the STI 5500 DVB descramblers. So again, it is a DVB compliant chip. This is the heart of the set-top box. It runs pretty much everything. It's quite interesting to look at this. And let's go down and there's the pinout. And right here, CAS, I'm not sure if that's Conditional Access System 1 and 0. Are those smart card serial inputs? I believe so. A little bit more down here. Let's see what else we got. Smart card interfaces right here in the flow chart. So yeah, input, output. That's bidirectional and that's input, and there's all your output. So yeah, anyways, very interesting. Okay guys, now that you have a better understanding of what DVB was all about and what it stands for, and a little bit about the Omega series of set-top box chips, the STI 5500 series, there it is there, the set-top box chip that runs it all. And this chip, yes, was DVB compliant, and why Dish Network decided to use it just made things simpler. However, the access card is simply a peripheral of the Omega. And in reality, the access card, it's not even needed. Throw it away. A virtual image of that card could actually be run in memory. And there is the ROM and there is the RAM. So an image could be loaded into RAM and run virtually. And that's exactly what happened. The first thing I actually saw was a flash file for a 2700 receiver. That was hacked, a firmware. I burned it into this receiver, and sure enough, this receiver ran without an access card, opened all the channels. It was just unbelievable. Seeing that was kind of like, it was like a weird dream. It was surreal. And the next thing you knew, somebody was making their own box, and that was the Blackbird. And there it is there, and it had the Omega chip, and you look closely, there's the ROM chip, just like in a dish receiver, and there is the RAM and the Omega chip in the center. And this guy sold for about 300 bucks, and it opened all channels on Bell and Dish Network. It lasted for about a year. The providers were very much caught off guard by all of this. There was no ECMs against FTA receivers for probably about a year. Like I said, they were very much caught off guard, but they became very aggressive later on because it was suggested that Dish was very upset about this for other reasons. Even back in the card hacking days when you actually needed Dish receivers, they were still selling that hardware, which people were using to hack with, but they were still making money on the hardware. But when things went over to the FTA boxes, they weren't making anything anymore. And I think that was really, yeah, that really pissed them off. So they got very legal about that, and they started going after a lot of companies like Pansat that were selling FTA receivers. And more on that in a second, guys.
Acapulco, Mexico, where we took 18 goddesses to have fun in the sun and participate in a wet t-shirt competition so wild you might get wet. Don't miss the Hot Body Wet T-Shirt Challenge, all this month on pay-per-view.
So the Pansat 2300 is the first legitimate free-to-air receiver that I know that was actually used for piracy. And it was all because it contained an Omega chip, the STI 5518, and also it has a JTAG interface. As you can see, it was utilized there. Now, the Omega has on board the diagnostic control unit for the JTAG, and it's just similar to the dish network receivers. The process is exactly the same with these receivers. So another compatibility with the dish network stuff. And, you know, the JTAG and JKeys was already figured out at this time. So all of this stuff lended itself to allowing an FTA receiver like this to be hacked for illegitimate purposes. And so as time went on, Pansat kind of noticed that, hey, why are these 2300 receivers, we can't keep them in stock, people are buying them all up. They looked around and they figured it out. So, well, they wanted to make things easy too with a purpose-built receiver. As I said before, money corrupts. They got into the game in a big way, and I'm going to touch on that too. But just wanted to point things out here. With the 2300, to flash a new bin to it, you either had to do it through the JTAG, which was a quick way of doing it, or you had to do it through the RS-232 on the back, which was the slow way of doing it. It took quite a while. I think it took about an hour. And once the providers caught on, they actually started to do ECMs against the virtual card that was running in memory. And so you had to get a new bin, and you had to upload a new bin to keep things going. And to make things easier, the guys over at Pansat, now I had a connection over in Pansat because I had actually done some work for them early on. And this is the reason why I actually had this 2300 receiver. I was testing for them die-set commands that they were doing different firmwares when this receiver first came out for motor control, for rotating the SG2100 motor that was available on the market very early on for rotating your antenna. I did field testing for them and gave them feedback, and I had a connection in there, which I stayed in contact with. And the feedback I was getting about what was going on was quite interesting because they were well aware of what was going on here, and they wanted a piece of the game. And they got into it in a big way. As I said, money corrupts. And they purposely built and designed this receiver here. Now, like I said, it was a difficult process for, you had to be a bit tech savvy to either use a JTAG or the RS-232. You also had to remove the receiver from your shelf by your TV, take it over to your computer. That was, difficult, time consuming. So Pansat went out and built the 3500. Now, this receiver lended itself to being hacked, okay? It had a SD card slot in there, which allowed you to easily, anybody could, flash a bin to this thing, and it was quick. You could be up in a minute again. Just download the file on a flash card, stick it in there, go to your remote, push a button, and you're back up. New bin loaded. We can take a look inside this guy. And, okay, the Omega, they put a heat sink on it because the Omega was now doing a bit more crypto. It was probably giving off a bit of heat, so to keep things cool and stable, they put a heat sink on there. They also added a card slot. I mean, that's not unusual, as some receivers, FTA receivers, do allow you to put a card in so you can subscribe to some programming. That is, again, a European thing, European Union thing. So not unusual to see it. However, the fact that you can read cards opens up the receiver to doing even more hacking in a lot of different ways, like card sharing. So why they put that card slot on there probably was a good idea, they thought. Anyways, Pansat, well, I'm going to show you this guy. We're going to power it up. It's still got a blacklist bin on it. And we're going to hook it up, and we will look at some FTA programming. Legitimate FTA programming, I should say.
I'm Ginger from American Ecstasy. When you see a scrambled picture on this channel, don't worry. We'll be testing the uncensored American triple ecstasy every night at 10 p.m. Eastern. It's so hot, we have to scramble.
So now that you had your FTA receiver up and running and you were able to get both Bell and Dish, and you needed to have a satellite antenna that was capable of receiving 4 different satellites, because Bell had 2 satellite locations and Dish had 2 satellite locations that you wanted to go after. And the way to do that, to keep things simple, was to get one of these oval antennas, and which had multi-LNBs on it. What you would do is modify it in this sort of a way here and add an additional LNB on one side. Typically, the one in the center here is, that would be aimed at, say, 101, then you would have 110, 119, and over here you would have 91 and 82, which were the Bell satellites. And you would run the cables from all of those LNBs into these things called dissect switches, which these are 4-way switches, 4 satellites, and this is the output here. Single cable coming down to your receiver, and in the menu you would set for each satellite 1, 2, 3, and 4, the dissect selection. And yeah, basically the receiver would send a signal to the switch, and you had the choice of 4 different LNBs. And that's how that worked. Kept things simple for a lot of people. Now, there were some additional satellites, and some people got even fancier. There were 8-way switches, and you could tune in all kinds of other things on different satellites. Some people went with KU band dishes, 30-inch dishes for fixed satellite services, and blended in other things too. It was an FTA receiver, so you could actually use it for legit FTA as well, blended in with your pirated stuff. So that's how that worked. It was a pretty amazing time to be able to do this. So yeah.
So if you're watching me, you're a satellite pirate.
So as I stated earlier, I truly believe that the Pansat 3500 was purposely designed and built to enable piracy, mainly because of the card slot through the front that allowed you to flash a new bin file or firmware to the receiver. Under normal circumstances with an FTA receiver, you would never ever be updating the firmware on your receiver. There would really be no need to. So the fact that this enabled that and allowed you to do that easily shows what it was all really about. Now, Pansat took things to a whole new level. They weren't just enabling you to be able to flash a bin. They were also providing the bins, but they were doing it on the underground. They hired hackers to create bins for their receivers. And there was a hacker known as Blacklist online, and whenever the Pansat receivers would go down, everybody was waiting on Blacklist to release another bin. Well, Blacklist actually worked for Pansat. It was a conspiracy. It got found out. And Dish Network and Nagristar launched a massive lawsuit against Pansat, and they won that lawsuit, and Pansat was ordered to pay Dish Network and Nagra $121 million, and they were also barred from shipping any of their equipment into the United States. Permanent injunction bans FTA distributor from trafficking, okay, which pretty much killed Pansat. And to me, that was kind of sad, because Pansat in the beginning was a legitimate company and made some really good products that are sadly missed. So, as they say, money corrupts, and they went after the money, and they thought they were safe, I guess, over in South Korea. But they weren't, and that spelled their own doom. So, unfortunately, that's how it was. Anyways, we're going to fire this guy up right now. We're going to connect him to a TV, and we're going to connect him actually to a satellite antenna. We're going to do a scan, and it's just going to be kind of cool to see this receiver working after such a long time. Okay, guys, stick around. That's coming up next. Okay guys, I got the Pansat 3500 here all set up. In the back here, I have it connected to a satellite outside antenna, which is aimed at 97 degrees KU band, which is Galaxy 19. And this little box here is a cute little accessory. It was a UHF remote. Worked on any Pansat receiver, just plugged in the back. So I'm using one of those because the original remote I don't have anymore. Now this is connected up to my monitor here, and of course we have no signal. So we're going to go down here and we are going to plug that in, and we should see the Pansat here powering up momentarily. There we go. See the B80. You guys that had these receivers probably remember what that stood for. And okay, we have no signal, obviously, as it is not configured properly. Now I will get the remote for that Pansat UHF remote and push. Now you guys will probably remember the X05BL stood for blacklist. Last time it was updated was August the 2nd in 2008. That was probably the end of the FTA era. It lasted a few years, but yeah, 2008 was probably the end of it all. And we go into the installation menu, and remember the password was always 0000 on these things. And antenna set up. Let's go in there. I don't really care what satellite I'm on, but I do need 10750, which is the LMB frequency. So that actually looks good. Let's exit that. And let's do a blind scan. Okay, let's start that scan. Should pick up something. Oh yeah, look at that. See, we're getting something there. It's picking up something. It's found a transponder. Very cool. So as this scans, I am going to read you. Pansat was not the only FTA manufacturer. When things really started to heat up and everybody wanted an FTA receiver to hack with, it was unbelievable the amount of companies that started to show up out of the woodwork and manufacturers that were making FTA receivers that lended themselves to being hacked. And here's just some of the names I found online. BuzzSat, BlueJay, Blackbird, Diamond, DigiWave, eBox, ExpressVU, Fortech, HomeSat, Icon, Envision, VisionSat, Aurasat, Pansat, of course, who we know, Skyview, ScatPros, Setopia, CSAT, SmartBox, SatCruiser, SuperSat, TestSat, SpaceStar, Captain, Captive Works, CoolSat, DreamLink, FreeSat, LimeSat, NanoSat, NeoSat, ProSat, ViewSat, and SonicView. Those are only some. I'm sure there was more. But yeah, all of those guys got in the game, and some of them also were also sued by Dish Network, Nagristar. But Pansat was the one that I know that was sued the most, $121 million. So anyways, guys, this is probably going to take a while. I'm just going to stop it, and I'll come right back when it is done. Okay, it's finished doing its transponder scan, and now it's scanning for channels. Saving, please wait. Looks like it's done. Yeah, hey. Wow, we got some TV going here. Now this is legitimate free-to-air, and this is what these receivers were originally designed to do. This is totally free programming that you can receive off of the satellite. Let me just exit here, and there we go. Let's see, channel list here. So Nat, like I was saying, if you're a guy from Thailand, I believe this is a Thai channel. So how do I do this? Yeah. How do I turn up the volume here? There we go. We can learn Thai. Okay, channel list, I'll go back. Good idea. So lots of channels up there, free to air, legitimate, free to air. Let's see what this one's about.
متخصصين في نشر الوعي حول أهمية الحياة الرقمية الآمنة بين زملائهم في المدارس، حيث جاء هذا البرنامج بالتعاون مع عدد من المؤسسات.
كل هذه الأمور كل هذه المحددات.
Was Palestinian channel. Well, that's interesting.
عبارة عن إبر تفكير. الحل الجذري
هو حل سياسي جذري للاحتلال.
السيطرة الفلسطينية على المعابر بإتاحة الموارد كلها الفلسطينية.
So lots and lots of channels that you can still pick up. Let's check out Libya. This is what's on TV in Libya right now. The favorite Libyan soap opera of the day. So go into channel list here and see what else. So, like I said, this is legitimate FTA, and this is what these receivers were intended to do originally, was to pick up stuff like this. Oh, there's a German channel. Let's go check that out. Okay guys, I hope you enjoyed today's installment on the history of hacking satellite FTA, and stick around for my next video, which will be on IKS card sharing and these dream boxes, how it was done back in the day too. Really cool how these things worked. You could put a card in here and share it across the network to other dream boxes, which could be in your house or in another country. Really cool. We're going to dive into that next in the next installment, which is coming up soon. So look out for that. I'm also going to look at Enfusion, which was really popular, and their Nova and the Sun server and all that other stuff, which you guys probably remember. This was an era that followed the FTA era. And basically, instead you didn't have to maintain the receivers anymore. They did it on their end thanks to the internet connection. Okay, guys, have a good one.
They observed what they appear to be as telecommunications being intercepted and being taken via the internet.
In other words, the police noticed that the family's home entertainment system was set up to illegally pull in satellite television programs. The theft of telecommunications services was just the tip of the iceberg. Police seized 17 satellite receivers, 2 receiver dishes, 30 digital access cards, and a computer system used to rewrite receiver cards.
Hey guys, welcome back to the channel, and today another installment of the history of satellite hacking. And today we're going to look at Enfusion. You guys probably remember these Enfusion receivers. The one on the top was a standard definition, sold for about $100. And the one on the bottom was the Cadillac. It was the HD unit. And it sold for about, I remember, about $500. And we'll get into the more details on that shortly. But for some of you that this might be the first time you're watching one of my history of satellite hacking videos, Going to start off first with the first method that was used, and that was to actually hack the real McCoy receiver. You needed an actual dishnet receiver, and you attacked the access card. We would reprogram that card. And around 2004, there was a watershed moment where all of a sudden you didn't need the actual provider equipment anymore. You didn't even need an access card. You just had to buy one of these FTA receivers. And what they were actually exploiting at that time was the fact that this receiver used a standard FTA DVB compliant chip, which was readily available. And they went out and there's the DVB logo. This box had the same chip in it. The other thing is the access card could be fully emulated in software. So an access card is actually in the software of this unit. So the FTA receivers allow the end user to reprogram them by just taking an SD card out and flashing that on your computer, bringing it over, popping it in, pushing a button on your remote. The receiver would update the bin and you had updated your access. Now for the first year, these FTA receivers really caught the providers off guard, and they didn't have any ECMs or any countermeasures against them. However, about a year later, they really started to go after them. They figured out ways and methods, and it became a problem. You were basically reprogramming your FTA receiver every night. You're opening this door, you're taking this out, you're putting it in your computer, and maybe an hour later it would go down again, and you'd have to do the same thing, and it got to be a little bit annoying. Well, guess what, guys? The internet came along, and all of a sudden, a group of guys calling themselves Enfusion decided to make FTA boxes, DVB, that, yep, the DVB, there it is there, had an internet port on the back. And if we go around and we look, there it is there, and there it is there on that one. So all you needed to do to use these boxes was plug them into the internet. And it was all magic from that point on. Pure magic. It was so great, and at least a year or two, nothing happened. Whatever the providers tried to do, they could counteract it on their end, and Fusion could, because they had control over your box. It was pure luxury. You didn't have to do anything anymore. You just had to sit down and enjoy your TV. And yeah, things were great for a while. And how this actually worked was not only could the firmware in the box be updated over the internet, the actual card, or what we call the control words, the internet key sharing, that was all done from a server remotely. Now where that server was kind of secret. I did trace an IP, and it was going to Hong Kong, so it was definitely offshore. The amount of data that was going back and forth to do this was very little. The timing wasn't too critical, so you could have a bit of latency on it. And yeah, it worked wonderfully. And it didn't just do Dish, it did Bell as well. And this here is dissect switch. And this is all you needed. Actually, I'm gonna maybe have to stop the camera. Oh, no, we're good. There we go. So this was a 4-port dissect switch, and that in the center there, that went to your receiver, and the other 4 were your LNBs, and these are LNBs on a satellite dish. And you used one of these dishes. It was just a oval, I think it was about 20 inches, 20 by 24, I believe this dish is. Multiple LNBs, and you could even put even more on it. You could actually have 5 of them, and that allowed you to receive all Dish Network satellites and all of Bell satellites, and yeah, into your Enfusion receiver. The amount of channels, you had 1,000 channels, and you didn't have to do anything. It was absolute pure luxury. These boxes sold like crazy. Yeah, guys, it was great. So hold on a sec. I'm going to actually hook one of these up. And we're going to see what it does. Actually, it is hooked up, but we're going to hook it to my monitor, and we're just going to see what kind of menus come up, what it displays. Now, as time went on, Enfusion kind of disappeared. And the reason why was because you just bought the boxes. You didn't pay them anything. So their business model was to make money off of the hardware. And eventually they reached a plateau and they kind of disappeared with the money. And that's where these came into play. Linksys boxes, the GLs, or the, what was it, the WRT 54. You could subscribe to an IKS service and still use one of these boxes. However, it was hard-coded in these boxes what IP number they connected to over in Hong Kong. So you would put a script on your Linksys box called GOO, and GOO would basically intercept that IP and forward it to whatever IP you wanted it to go to, whatever service. So what that was also telling us was Enfusion wasn't really doing anything special and not encrypted or anything. It was pretty straightforward the way their system worked. And another service could actually provide the same internet key sharing to these boxes. And that worked for a while. But eventually it just was kind of a pain in the ass because sometimes the Linksys box would go down or something would go wrong, and it was kind of a headache. So a lot of people just started buying new boxes that they could just, on the box itself, set the service provider. And okay, guys, so there's the two remotes. Actually, I love that HD remote that came with it. It was really cool, nice and big buttons on it. So what we're going to do now is we are going to play with these boxes and hook them up, see what we can do with them, see what they show us. Okay, guys, stand by. Okay, guys, we are now going to check out the two Enfusion boxes. The HD box I have connected to my monitor, and what was cool was had this door that opened on the front. I had a slot there for an access card. Was that a USB? There was some control buttons, and I love this fluorescent display. You don't really see those displays much anymore. Really cool. Yeah. So, and the one up in the top was really just kind of the cheapy box. It had the LED display on it. But the remotes that they give for both boxes was the same codes. You see, it will. Yep, see, look at that. It's working on both. Anyways, let's go look at the monitor here. And as you see, I am going to press menu. And there we go. Oh, we had a game on it too, it looks like. Oh. It's taking a little bit of a lag on there, responding. Oh, I see. Gotta go here. Is it gonna work? Oh, there we go. Let's press 1. Oh, wow. I never even knew that this existed. I don't even play this game. Anyway, back to the menu. Very laggy remote. Menu. We need to press exit. Okay, that's what it is. Okay, so system information. Oh, we got to go back. There we go. System information. Weather forecast. CA, that's conditional access. That would be interesting. Okay, smart card. No card, yes. Edit code. Let's go in and look. Oh, you see, so you got via access, or whatever that one was. So we got Nagra, probably Xcrypt, Beta Crypt. Not sure what the C one was. But anyway, we were dealing with Nagra, and look at that. 7,000, I think that was Bell. What's on the left is the provider ID, and there's always the two keys, the 0 and the 1, because they would roll. So let's go down and, not sure, I think that was Dish Network, the 00. It looks like a bunch of other providers here. So this box was obviously used not just on Dish and Bell, but probably globally. I heard it was used on a system in the Philippines and in South America. Different systems down there as well. So, yeah, there we go, guys. Let's try the guide. Oh, okay, so terrestrial. That's true. I did have it hooked up. It was probably last used for terrestrial TV. And there are the satellites that it was using. See, now SEAL was the HD satellite for Dish Network. So let's go look at that. Oh yeah, WB. These are some of the channels in HD that it had. Look at that. Homes and Gardens in HD. Wow. Very cool. Nat Geo. So yeah, this is probably, don't see the date on here. I am wondering if we can go into the menu again and go into information and see if it, STB information. Okay, July, date July, okay. Okay, so the time, I've closed the menu and opened it several times. The time is not changing. It's staying at July 1354-17. So it is stuck in time, and that's probably the last time, but I don't know what year this was, but it's been more than 10 years. So anyways, guys, we are going to now open these boxes up and take a look inside. The HG unit especially is interesting because there is a separate card that you had to install to actually get it to work. And they did that for a certain reason, and I'm going to explain that next. Okay, guys, there we are with the cover off on the HD box. And yeah, it's a very nice, actually, receiver inside. Now, the cheapy one, the $100 one, was an all-in-one board, integrated power supply right on the main board. These things ran kind of hot and didn't last that long. If you got a couple years out of them, you were lucky before they went kaput. But it was a cheap box. It was $100, and that's all you had to pay. And this one over here, the Cadillac, as I call it, had a separate power supply, which was actually very nicely made. And okay, so here's where things got interesting. To get HD off of Dish Network used a proprietary forward error correction, and they called it Turbo FEC. And only their receivers had tuners that could tune a Turbo FEC. So in order for this receiver to work and be able to receive Turbo FEC, it needed a custom tuner, which is this chip here. And this board here was sold separately. And the reason they did that was they could not openly sell a receiver that could receive Turbo FEC or decode it, because that would just be outright, you know, hey, come get me. You know, I'm selling receivers that are designed to, you know, be used on Dish Network. So what they did is they sold this box as an FTA receiver, and you had to buy from a separate source, totally sold separately, this board here, and you had to install it and plug in these ribbon cables, as you see here. And on the back, you had to put this jumper in between here and here. And what was really interesting was they were trying to disguise, they had a hole on the back, a knockout, with a little rubber plug in it, and it said UHF remote antenna. Okay, so they were disguising that hole. If anybody said anything, well, you got a hole in the receiver for this thing. No. That hole is for the UHF remote, which didn't actually even exist. The whole purpose was, well, it was a conspiracy, right? They knew they couldn't sell the box openly with the ability to tune into Turbo FEC. So they designed it with the hole in the back, called it a UHF antenna hole. UHF remote never existed for this box. However, they sold these boards separately, and you could buy them, you know, kind of underground on different forums and whatever. and you would get it and you would pop it in your box, plug it in these ribbon cables, put the jumper on the back, and voila, you had a receiver. Now that could tune to TurboFEC and tune into Dish Network's HD channels. So guys, that's how that was done. And what we're gonna do next, I'm gonna show you some videos on YouTube I found of people actually selling these boxes. It's still on YouTube, it's really funny. Probably one of them was from about 13 years ago. So here we go, guys. We're gonna take a look at some videos now, stand by. So here was a guy actually 13 years ago selling Infusion receivers using YouTube.
Hi, my name is Mac. Welcome to IncredibleFTA.com. We are viewing Infusion Phoenix, a slightly advanced version from their basic model Solaris, and we're going to go over some of the functions and features of this receiver with you. In the front panel, you can see that they...
Okay, we're not going to listen to him. He's kind of boring, but just interesting seeing somebody was doing this on YouTube. You get 2 thumbs up. And somebody down here left a comment, said this product doesn't work anymore. Lol, haven't you heard of IKS or card sharing? Yeah, let's go click on his store link here. And as you see, he's no longer around. Okay, guys, that was kind of funny. Powered by Infusion. Was quite a cool name and quite a cool concept how all of this worked. These boxes connected out to the internet, to some type of a cloud server, or servers that were scattered all over the world, and those servers were known as the Sun servers. So there you go, guys. And what we're gonna do next is I'm gonna actually try to hook one of these up to the internet, and we're actually gonna run it through one of these Linksys routers. And we're gonna see, looking at IP tables, what it's trying to connect to. That'll be interesting. Okay, guys, let's do that next. There's a Meshtastic under test in the backyard. Testing has been going really good. But today, we're looking at Infusion, and we're going to check out the Infusion receiver, what IP it connects to. So what I've done here is I got this Linksys router going. The yellow cable is my computer. The white cable next to it is going over to that Infusion HD receiver. And the other one is connecting to my house internet. So guys, this is what we're gonna do. DDWRT is running on that router, and it's gonna allow us to see what the connection is when I turn this guy on here. So let's do that now. And we'll wait for it to boot up. It is loading. And up there, as you see, it's saying no signal. Okay, we're gonna have a signal momentarily. Detecting device. Says it is, okay. Channel 251. It's not displaying anything yet. It's doing something here, the WB. Okay. So what we're going to do is we're going to go over here and active IPs 65. Let's look at this table. Okay, the 122 is my computer. So we are looking for an IP other than ending in 122. Not seeing it yet. Okay, there was a problem. It was set to a static IP, probably because it was being used with GU before. So I put it to dynamic, and look at that, it's got the IP 115. So if we go back over here now, we reload this page. Let's see if we got any 115s on here. So what I've done is I switched to the SD unit, the cheapo box, and I got it connected to the network. And as you can see, the lights are on, and it's acquired the IP ending in 131. Come over to the computer, and we can see 131. It's got a host name of HomeNet, but there is 0 connections going on, and that is interesting. It appears that it doesn't connect to the server or the Sun server until there is a satellite signal. That kind of makes sense because there would be no point in making a connection until it really needed to, because it would put a lot of extra traffic on their network. So what are we going to do? We're going to connect a satellite signal to it. Let's see what it does. Stand by, guys. Okay, guys, I'm down in Patch Bay, and I just want to show you what's going on down here. These are all different satellite dishes I have up on the tower and on the roof. There's one on 97 degrees. There's 110, which is dish. There's 119. 129 is actually no longer around that satellite. Defunct satellite. That was a SEAL satellite that had HD for dish originally. There's 82 HD for Bell. And then we're going to have 91 Bell. And then over here I've got the rotor, dish on a rotor. We have circular and we have linear. And then there's a couple test ports. So guys, I have connected this cable here, number 38. That's going up to the kitchen. So I'm going to give 119 satellite. That's Dish Network's main satellite. That is going to be going to the box right now. And we're going to see if we get a connection now. So there's cable 38. We got a splicer. We'll bring it down here. Things are getting kind of crazy here with all these wires. But hey, this is experimentation and learning. This is getting interesting. I tried doing it with the SD receiver. Couldn't pick up a thing. What I found is there's really nothing that isn't TurboFEC anymore up there. So this receiver is pretty much useless now to do anything with Dish Network. So I've gone over to the TurboFEC unit, and look at that. See that green line? That means we have a good signal, a signal that it understands. And that is a TurboFEC signal, because I can tell by the FEC that they're using. If we go over here, we can see right there, you see that 21500. That is usually what they use for TurboFEC, is that symbol rate. So 12253, and we are going to try to find those channels just for fun. Anyways, here we go, guys. Let's see what happens if we do a TP scan, which is the green button. Let's push the green button, and away it goes. Let's see what we get. Okay, got PBS. Okay, well, as long as we got something, it's going to cause the box to connect. Here we go. That's why we're doing this. We're trying to stimulate it to connect to the Sun server. Exit. And let's go to the guide. Okay, let me take a closer look. Hold on, guys. Okay, PBS station, the one we scanned in just now. Let's go to it and look what we get. Sun's disconnected. Okay, so that means it's tried to connect to the Sun server. Let's go look at the IPs now and the IP tables. Stand by, guys. There you go, guys. There it is, HomeNet. IP ending in 115. It has made 3 connections. Now 2 connections. Okay, the first, it's probably one of them was a DNS query. So let's go over system info and status. And we can find out down here the connection log. Let's see what it's doing. Oh, I saw it. Okay. Right there. Oh. It's trying to connect to that 210 IP. We'll have to look that one up. What other ones? There's another one. I just saw it there. Another 210. Look, port 3470 unreplied. Yeah, I guess. But 210, that sounds like Asia. An IP starting in 210. I'm just guessing, but that sounds like somewhere over in Hong Kong or somewhere. There's another one. Unreplied. Okay, it keeps hitting the same IP over and over again. Okay, so that's what it's doing. It's looking for multiple times. It's trying to hit the same IP. Where was it again? There it is there. Okay. So it's that IP, 210. Copy. And now let's go over to Aaron. And we will query Aaron, the American Registry of Internet Numbers. The best place to do your IP who is China. Wow, it's Shanghai. These guys weren't fooling around, were they? I knew it was Asia. Well, there you go, guys. So, Enfusion tied back to China somehow. It must have been the triads or who knows what. Definitely organized crime. Okay, guys. Well, we figured that out. That was kind of cool. Shanghai. So there you go, guys. Internet connectivity changed the game. When it came to Enfusion, it was a whole new era of satellite hacking. These boxes made it easy. You just had to buy the box, plug it in, connect it to your satellite dish, and voila, you had TV programming. Look at that. It's actually working. It's actually picking up a couple of channels. Those channels are actually not encrypted. That's why they're coming in. However, those are turbo effect channels. You would not be able to pick those channels up without a receiver with a turbo effect tuner. A real dish network receiver wouldn't allow you to get those channels still because it wouldn't have authorization on the card. So there you go, guys. I just want to say Enfusion was a really cool time. It was a really cool era. It was a game changer. It paved the way to IKS internet key sharing, which suddenly became a very commonplace following Enfusion. And later on led to actually IPTV, which is what we know today. So there you go, guys. Have yourself a great Easter and don't eat too much. Okay, there we go, guys. Wheelers and dealers. Wow, that's actually kind of funny. The wheelers and dealers.
Reference all those years.
Enfusion, those guys were the wheeler dealers, man. Coming up with this concept. It was brilliant. Really brilliant, brilliant concept. There you go, guys. Have a good one.
Hello. You're watching Dish Network's Pirate TV channel. Did you know you're not an authorized subscriber? That's right. I'm speaking to you on a channel that only someone receiving programming without proper authorization can view. So if you're watching me, you're a satellite pirate.
Hey guys, welcome back to the channel. And today I'm going to play you a video from 2001 on hacking access cards. Now this was actually a new special done by Tech TV. Probably remember that channel if you were around back then, but it was an episode of cybercrime and it was about hacking DirecTV cards and the whole scene and situation that was taking place. And it was pretty cool at that time. And Tech TV did a really good documentary on it. And I found the tape, and I'm going to play it for you guys. And yeah, it's pretty cool, actually. I think you're going to like it. It also covers hacking cable TV in the day, which was also something that was kind of popular besides satellite. So here we go, guys. And I'm just going to fire up my encoder here, which is going to convert this tape. And here we go, guys. I hope you enjoy it. All I gotta do is press play. Here we go.
Welcome to our Stealing TV special.
It's Cybercrime's half-hour look at how crooks are using technology to pirate TV.
Everything from hacked smart cards to splicing cable wire.
For satellite TV providers, it's a cat and mouse game. If you walk into an electronics store and walk out with a television without paying for it first, that's stealing. It's doubtful anyone would argue otherwise. But if you sit in your living room and watch satellite TV without paying a monthly subscription fee, that's also stealing. Yet thousands and thousands of people do just that. DirecTV has tried numerous times to stop the signal thieves, but with limited success. Here's why.
This is a Peace Arch border crossing. In November 1995, during a routine customs examination, an individual arriving from Canada was referred to Customs Secondary.
What began as a routine inspection became anything but routine. Thomas Smith is a senior special agent with U.S. Customs.
Our customs inspectors, during the secondary exam of the vehicle, discovered 110 green plastic printed circuit boards that the individual had failed to declare to the customs officer. This individual stated that these were gaming devices for like a Nintendo type game.
Nintendo circuit boards smuggled across the U.S.-Canadian border? Hardly. The mystery circuit boards turned out to be the first generation of pirated access cards, designed to steal DirecTV's programming.
You are now authorized to receive everything that's broadcast by Direct Television. All of the pay-per-view channels, all of the sporting events, all of the things that you would normally have to pay money for, you can now receive
for absolutely free. And finding hacked access cards is easy. Cards are advertised everywhere, from the newspaper to the net. Rudy Orhalis is with the Computer Crime and Intellectual Property Division of the Department of Justice.
There are literally hundreds of thousands of these cards being sold through the internet and through other sources. So Direct Television estimates that their annual losses is in the millions of dollars.
These smart cards, or H cards, are the key to DirecTV's programming and revenue. When you sign up for service, DirecTV tells a chip inside the card what package you've agreed to pay for. The card slides into the back of a receiver like this, and now you're surfing satellite TV. But hackers have figured out a way to alter the chip inside the card, giving it new instructions. In essence, telling the card you're authorized for every type of programming offered by DirecTV. And the only cost? The receiver and card.
If you go to the web, to the internet now, you'll find that there are still a number of sites that are offering these cards. And they range anywhere from $300 to $500 per card.
A one-time cost compared to a subscription fee that can run as much as $83 a month for all programming except for selected pay-per-view channels. Add those, and your bill adds up too.
Assuming that you would normally have to pay about $105 per month for movies and programs and all of the Showtime and HBOs, you figure it's going to take you 3 months to recoup the money that you've invested in this card. Anything after that is gravy.
And if you're a sports or movie fan and order a lot of pay-per-view channels, that can turn out to be a lot of gravy. But why are the cards coming across the border in Blaine, Washington? In Canada, DirecTV does not have a license to broadcast its satellite signal. Therefore, it's not a violation to steal it, which is why a number of websites selling pirated access cards operate here. But once you cross the border into the U.S. like I've done, that's a different story.
Historically, Canada has been a hotbed of satellite piracy.
Larry Rissler is a retired FBI agent who now heads up DirecTV's signal integrity team. It's his job to protect DirecTV's programming.
The satellite signal, although intended for the United States, the footprint actually spills across the border into Canada and Mexico and even further than that. It would be like shining a flashlight on a wall to illuminate a speck. You would illuminate the speck, but the outside edges of the flashlight's footprint also cover other areas of the wall.
But again, since DirecTV's programming is not supposed to be received in Canada, the only way to watch it there, regardless of the satellite footprint, is to steal it.
As a result, many of the individuals who are responsible for developing the hack for the DirecTV system have and still reside in Canada.
So who's buying the hacked access cards coming across the border, and what can be done to stop it? Up next, custom agents go undercover to catch potential buyers and distributors in the U.S.
Every person that came to the website, yes, did know that this product was illegal. We either told them in our telephone conversation or they read it on the internet website.
Regardless, thousands of illegal access cards are bought during Operation Smart Card. Our special report on stealing TV continues after the break. Welcome back. 6 years ago, DirecTV began broadcasting its signal, and ever since that time, it's been fighting satellite piracy from people who've persistently figured out ways to get around paying for it without getting caught. Now the federal government is joining the fight with the largest undercover sting operation targeting smart card buyers. Here's a conclusion of our story. DirecTV, the company responsible for bringing satellite TV into 9 million homes across the country, is in a war. Not against other satellite providers, but against hackers who've unlocked the key to stealing DirecTV's signal right out of the sky.
It's called the black market.
A black market that yields plenty of green. One of these hacked access cards sells for as much as $500. And while DirecTV won't put a dollar figure on its losses, Larry Rissler, head of the company's signal integrity team, admits the hacked cards are hacking into DirecTV's revenue stream.
Clearly it's a problem. We've never quantified it. I don't want to overstate the problem, but yes, we are denied programming revenue and we incur significant costs as a result.
Standing inside DirecTV's network management center, it's easy to see why DirecTV would want to protect its property. You're looking at more than 400 channels of paid programming. In the past, DirecTV has launched electronic countermeasures. This entails sending out a signal that disables pirated access cards. It was called Black Sunday, January 21st, 2001. For those using hacked access cards, it was the day DirecTV died. TV screens across the country went blank except for this message, a temporary setback for those using illegal cards.
On occasion, the ECM will actually fry the software, making it unusable. In some instances, it just simply stops the software from using as long as the signal is in the data stream. In addition to that, we have, of course, also swapped out our access cards on one occasion, sent out new cards with new codes. Unfortunately, they were hacked.
Just one of many attempts to stop signal theft. The other, and perhaps most significant to date, Operation Smart Card, conducted by U.S. Custom agents in Blaine, Washington. Since 1995, agents have seen illegal cards coming across the border, but haven't been able to touch sellers operating websites in Canada. So agents decided to go after U.S. citizens buying and distributing hacked cards.
This was the first case that had ever been done of an undercover nature where there was any internet involvement.
Senior Special Agent Joanne Zylstra is with U.S. Customs. Her small team decided to beat access card buyers at their own game with a phony website designed to look like the real thing, right down to the legal disclaimer.
Every person that came to the website, yes, did know that this product was illegal. We either told them in our telephone conversation or they read it on the internet website.
But that didn't stop people from flocking to the website. Before long, custom agents were operating a booming illegal online business.
Joanne, look at this order that we got.
For 9 months, agents operated the website, which is now offline. The main goal was not to identify individuals buying 1 or 2 cards. Rather, agents were trying to locate people acting as distributors who would buy cards in bulk and resell them. Although most of the transactions were conducted online, there were some phone calls and sometimes face-to-face meetings.
It looks like probably about 100 cards a month for me. You know, that would be comfortable. If I get any bigger, you know, that's in the 3 areas I'm in now. Yeah. Once I get that settled, once I get everybody settled in that, then I'll start going to other cities.
The man sitting on the couch turned out to be one of the largest U.S. buyers and distributors. We can't show his face or give his name because he's still awaiting sentencing, and this undercover video is evidence in the government's case against him. but according to agents, he bought more than 600 hacked access cards. Other evidence was also collected, like photocopies of money that changed hands, cards that were sold. And by the time the website was taken offline,
more than 3,000 cards were sold to about 120 individuals. The amount of revenue collected from people wanting to purchase these cards exceeded $500,000.
Rudy O'Hollis is the coordinating prosecutor for Operation Smart Card. Ultimately, 15 people were arrested and charged in connection with a plot to steal DirecTV's programming.
It is a form of piracy. There are copyright laws that are being violated. We refer to people who buy illegal software as pirates. And these people are doing the same, except that they are, what they're purchasing is an illegal card. They're allowing these cards to be, maintain a market for and a demand for these cards, and they are supporting a type of piracy.
And although DirecTV is the obvious victim, it's not the biggest loser.
I think end users should be aware that piracy is not a victimless crime. There are victims. That includes DirecTV, our retailing outlets, as well as our consumers.
It's not just Direct Television that loses out on this. Don't forget there's a movie industry that's attached to this. There are a number of other industries that receive revenues, for example, from Direct Television.
Next on HBO.
And ultimately that means higher costs that have to be shared by legitimate subscribers, which means those people who do pay end up paying a little bit more. So everyone ends up paying in the long run.
The man sitting on the couch in the undercover video is expected to be sentenced later this month. As for all of the hacked access cards sold during Operation Smart Card, they were neutralized once the investigation was over, and the money collected was sent to the Treasury Department. Still ahead on cybercrime.
The honest consumer that is paying cable TV rates are subsidizing the people that are stealing it.
Stealing cable, it's a billion-dollar business. When cybercrime returns, find out how you pay the price for cable piracy.
Sky. Meanwhile, cable piracy continues to run rampant. Last year, more than 11 million people stole cable TV, according to the National Cable Television Association. They cut into cable lines and install descrambling devices to steal everything from basic programming to pay-per-view movies. And the legitimate users, well, they have more to lose than you might think.
These people are stealing. It is not piracy, it is stealing. And I think piracy is this romantic word that's some swashbuckling thing, and it's not, it's stealing.
It's a $6.5 billion a year problem, according to the National Cable Television Association. Cable piracy. Stealing or intercepting a cable television signal without paying for it. You may think it's a war against big business, or even a victimless crime, but are legitimate users paying the price of piracy?
The honest consumer that is paying cable TV rates are subsidizing the people that are stealing it. It's a huge issue for these people.
Nigel Ives is on the board of directors with the California Cable Television Association. We caught up with him on one of his recent trips to the California state capitol. Ives was here to educate Congress about the costs of cable piracy.
That they are cutting into our lines, which also causes damage to our cable system, which we have to repair, so we have to send people out to repair it, and that also is an expense. And that is subsidized again by the honest people that are paying for cable television.
And there's another cost. Legitimate cable users are losing out on community money. A percentage of revenues cable companies collect from consumers is given back to their communities. They're called franchise fees. So, for example, in California, $800 million is lost in revenue due to piracy. And 5% of that, or $40 million, is the franchise fees that would go to local California communities.
With $40 million going into local communities, that's missing out that goes for policemen, firemen, schools. I think any community you talk to would certainly appreciate that kind of money coming in.
Stealing cable or assisting someone in stealing cable is a federal crime under the Integrated Cable Act. And some states go even further. There are dozens of state laws that make it a crime to possess, not use, but possess the equipment used to steal cable. Unauthorized descrambling devices are considered contraband. They're illegal by their very nature.
These were called pancakes, and that's what this is right here. It descrambles the channels automatically.
Detective Mike Menz of the Sacramento Valley High-Tech Crime Unit hunts people who sell, buy, and use illegal cable equipment.
You'll have an older type descrambler where they've replaced the chip over in the corner with one they've made off a EEPROM programmer like this. And they will sometimes solder it on top of another one like these are, but normally they'll just take it and solder it right into the unit, or they'll make a whole bunch of them like this at one time and then put them in units after the fact.
According to the cable industry, using an illegal decoder like this one cost the industry $4,000 in lost revenue.
Recently we took down a case which had about 150 to 200 cable boxes a month in their quantity. We ended up filling 3 vans full of equipment when we left that place in Nevada.
Menz's unit began investigating the case after learning that someone in California was buying all the used cable boxes they could find. And that person was ultimately connected to a supplier of illegal descramblers in Nevada.
This all added up to a total of over $4 million in just one calendar year.
Investigators confiscated detailed records of the sales, a list of people who allegedly bought the boxes, along with hundreds of illegal cable boxes and descrambling chips. Police say the business was run by 29-year-old Greg Edward Meskey from Reno, Nevada, and 29-year-old Robert Dale St. Clair from Richmond, Nevada. The men in this case targeted buyers by advertising in electronic magazines. But more and more cable piracy entrepreneurs are turning to the web to reach a broader target audience.
The 2 men arrested in the cable bust in Nevada were convicted of misdemeanor charges related to selling the boxes. And as for the list of buyers in the case, well, the cable companies are considering whether to go after each of them in civil court. Our Stealing TV special continues after the break.
Everything from decoders to how to do it, boxes, they actually have boxes for sale, books on how to do it.
Cybercrime goes online in search of the equipment and the instructions on how to steal cable television. Our overwhelming results when we return. Back to our story. In part 1, we told you that it is simply illegal to possess an unauthorized descrambling device in many states. Yet that hasn't stopped thousands of websites from selling the equipment openly on the net. And instructions on how to steal cable, we learned, are only a click away.
Black boxes, descramblers, decoders, converters, tools of the cable piracy trade, all openly sold online. Detective Menz showed us.
Type in cable descrambler and see how many websites come up. 8,200 sites came up that fast. Everything from decoders to how to do it, boxes, they actually are boxes for sale, books on how to do it.
And even if you're not looking, the scrambling devices may find you. One cybercrime viewer pointed us to this site. The site claims it's legal to own your own cable descrambling box, as long as you notify your cable company. But even if you do notify them, experts in the industry say cable companies never authorize these boxes. Aside from using the web to buy the equipment, there are online memberships like Cable Pirate 5.0. Cybercrime bought this service using a credit card at a cost of $19.95 a month. We then had immediate access to a site filled with how-to plans. Everything from how to descramble cable TV with aluminum foil, to how to clone decoders for satellite TV, to how to figure out which descrambling method your cable company uses. Cable Pirate 5.0 pointed us to their disclaimer, stating this information is for entertainment purposes only.
It's for entertainment purposes only. The plans themselves are not illegal to sell.
And while it hasn't been tested in court, the federal law that makes it a crime to assist in stealing cable might be used to prosecute such sites. First Amendment advocates disagree, and until a legal challenge is made, websites that describe how to steal cable remain online.
For now, law enforcement and the cable industry spends its time deterring individuals from actually using those online instructions.
And the more we do this, I think the more that the general public realize, people that are getting it, that it's not a joke, that it has significant fines and up to jail sentences, and they realize that it is a significant crime, and they are starting to come around and bring these boxes in and sign up to legal cable service.
For the first offense, federal fines for stealing or helping someone steal cable are as high as $50,000 and/or 2 years in prison. And in one recent civil suit in Illinois, sellers of illegal descrambling equipment were ordered to pay more than $29 million in damages.
So Alex, I guess the question is, are people just trying to save money, or is it part of a bigger philosophy that the airwaves, TV should be free?
I don't know. Should TV be free? Really? Well, we tackle that debate on the website. Go there at cybercrime.com.
And with that, we are out of time for our Stealing TV special.
But we appreciate you watching. We'll see you next week.
We'll see you next week.
Bye-bye.
Hello. You're watching Dish Network's Pirate TV channel. Did you know you're not an authorized subscriber? That's right. I'm speaking to you on a channel that only someone receiving programming without proper authorization can view. So if you're watching me, you're a satellite pirate.